In this lesson, we are going to learn how to move terms from rational form to radical form. This first problem you see is x to the 1/4. This would be considered rational form, and we're going to move it to radical form. Rational form, you'll notice that there is a fractional exponent. Radical form is where we'd have a square root symbol, or cubed root, or whatever we have, but some radical symbol. So for this one, the first thing you need to know is that when I am rewriting this, this number becomes my index. So my denominator is my index. My numerator is my exponent. And we've kind of talked about this when we were reducing square roots that had like the square root of x cubed. We did some stuff with this a little bit and kind of saw how that would work. But when I move this from rational form to radical, I would write this as the 4th root of x to the 1st. I don't need the 1 there, but I wanted you to see where that came from. So you can see how the 4 is in the index spot and the 1 is in the exponent spot. That process is how you always move things from rational to radical form. So the second one, the same thing would be done with just plain old numbers, not always variables. So again, this is my index, this is my exponent. So for this problem, I would have the 4th root of 26 to the 1st. If I could break down that 4th root, I would have to, but that's not a perfect 4th, so I'm going to leave it alone. That's my final answer. Again, the 1 doesn't have to be there, but I'm going to leave it there so you see where that 1/4 went. Number 3 now, 27 to the 2/3. This is my index. This is my exponent. So when I write this into radical form, I would say it's the cubed root of 27 squared. Now, I can find the cubed root of 27, and even if I couldn't, I can find 27 squared. So if that's something we need to do, you have to take care of that. You can't just leave it in this form. Notice in this problem, 26 to the 1st just is going to stay 26, so I had nothing to change there or compute. In this one, I know the cubed root of 27 is 3, meaning 3 times 3 times 3 is 27. So when I take the cubed root of 27, I'm going to get a 3. And then I'm going to leave the squared there and say that 3 squared equals 9. So I have to actually simplify it all the way. Sometimes when I move things to radical form, I'm going to end up with an answer that does not have a radical sign, and that's because it was a perfect cube or a perfect square or whatever we're dealing with. The last one we're going to practice transferring is x squared raised to the 4/3. Just as a rule reminder, you'll see listed right here. When I have x to the 4th raised to the 3rd, I have one x, so I multiply those exponents. So that would be x to the 12th. Same idea here. I'm going to multiply these two numbers, and this would be 2 over 1. So I have 4 times 2, which is 8. 1 times 3 is 3. So I have x to the 8/3. Now when I move it to radical form, I would have the cubed root of x to the 8th. Hopefully you recognize that I can actually break this down further. And you might have recognized it right here, because this is an improper fraction. That means that it divides into that number. If I wrote this as a mixed number, I would write it as 2 and 2/3. And this is how we learn to break these down. So I would say this is x squared, because of this 2, and then it's the cubed root of x squared. And that's how I have to break those down. Hopefully we're kind of getting the hang of that. If not, you can always ask me for more practice ones. We can do a few together. And that's the quick lesson on how to move things from rational to radical form.